Guys, please confirm to me. All of you get my voice on screen. Those are attending in online. Guys, please confirm to me. All of you get my voice on screen. Those are attending in online. Guys, please confirm to me. All of you get my voice on screen. Am I audible, guys? Am I audible? Yeah. Thank you. Thank you. Thank you. Right. Good evening, guys. Right, sir. In the last session, what we completed there in the content here we discussed now in the last class. And differences between Java and others. The topic we started there in the last class. In the differences between Java and others, just we have started our conversation. Now let us understand the content here. Introduction topic I started. In that introduction part, what we completed, just a Java history, the topic I completed. Java history, in the sense what there? Java history. Then what's the background story for Java? Why Java is coming? Only these few points I completed there. Okay. Then immediately we started with the differences between Java and others. In others part, what we have taken there, no, C and C++. These two things here I have taken there in the comparison. Then after that, from this, in the comparison here, what we completed there, if you observe this point now, first one is like what there, C and C++ are static programming languages, but Java is what there, a dynamic programming language. There are given some kind of points here. Now try to understand it clearly. I want to give some explanation. Already required points I have given there, but I want to give some more explanation. Now try to understand this clearly. Right, sir. For example, all of you observe this clearly. For example, I have written a program. I have written a program. This is what actually .java file. .java or .c, whatever it may say. For example, .c. I've taken it. Here I have written some lines of code, number of instructions. Here I have written coding part. Now tell me, all of you tell me, who has written this program? Developer or not? Developer, programmer has written this code. How programmer has written this code? Programmer has written this code in his understandable language. Developer has written this code in his understandable language. Am I right or not? So what is the developer understandable language? No, developer understandable language is what? High level language. High level language is what the developer understandable language. Got it or not? Fine. I completed this program. Then I have to execute this program or not? Everybody understand my point here. I have to execute this program or not? To execute this program, here we have to use a mission. Here we have to use what there? A mission. All right. Now here I want to say like what there? Execution. This is like what the execution. This execution would be performed by an engine. In the case of C, that engine is called as what there? C engine. C programs are executed by an engine, C engine. C++ programs are executed by an engine, C++ engine. Similarly, Java programs are executed by an engine, Java engine. Yes, sir. All of you are getting my point or not? C engine, C++ engine, Java engine. Python programs are executed by an engine, Python engine. So different names are available for Java engine and Python engine. Python engine is also be called as PVM. PVM, Python Virtual Machine. Java programs are executed by an engine called as JVM, Java Virtual Machine. In this way, here we are having some other names. So, okay, fine. This is C engine. Good. If you provide this C engine, if you provide this C program to the C engine has to execute that program and it has to give some output. C engine has to execute that program and it has to give some output. What is that output here? It has to provide there some output. Whatever the program we have written, as per that some output here we are getting. But here we have a problem. There is a problem here. What's the problem here? We are able to get now. Observe carefully. Now tell me, C engine is a mission or not? C engine is what there is a mission, just like a some hardware related, or maybe some engine, right? It's a mission. It's not a human being. It able to understand. It able to execute only low-level language representations. That mission is able to understand only mission language, low-level representation. But observe carefully here. Here we provided program in what language? No, high-level language. Of course, C programming language only. Int I is equal to 10 now, high-level representation. Say for example, what is this high-level representation actually? Int I is equal to 10 is a high-level representation. But what is this low-level representation actually? This is low-level representation. Zeros and ones is what their mission language, low-level representation. So we have written our program in what representation? No, high-level representation. But C engine required the program in what representation? No, low-level representation. Are able to follow or not? This is what their high-level. This is what their low-level representation. But there some miscommunication is available or not? Some miscommunication is available. So we are unable to execute our program in this case now. But I want to make it is execute. If you want to execute this program, then what we have to do there? Here we need to go for some approach. What is that approach here we have to do there? Now try to understand it. If you want to execute this program, first we have to convert our program from high level representation to low level representation. First we have to convert our program from high level representation to low level representation. Here I am going to take some converter or a translator. Here I want to take translator. Here I am going to take translator. Here I want to take this translator has to take this high level program as an input. It has to convert that high level program into low level program. The total low level program here we are going to get in the form of a separate file. Low level program here we are able to get in the form of what there? A separate file. That file is like what there? .exe file. Inside this .exe file, then what we are able to have there? Here we are able to have like what there? Low level representations totally. Here this is totally what there? Low level representation here we can understand. Right, sir. These are like what their low level representations. Right, sir. We can understand this. Low level representation. This is low level representation. Okay. Whenever we are getting this low level representation, if we give this low level represented code to the C engine, now C engine will execute this low level code. C engine is able to provide the required output. C engine is able to provide what there? The required output. Now this is what exactly the process of executing our program. Are you getting it or not? Now you understand it clearly. Here we have used some translation process to translate the program from high level representation to low level representation. Now this translation process is called as what then? Compilation. This translation process is called as what there? Compilation. Now tell me here, what is the meaning of this compilation clearly? What exactly the meaning of compilation here? If you observe this point here, answer is very clear. Compilation is a process of converting program from high level representation to low level representation. This is point number one. Okay, observe carefully. Again, I'm asking there, what exactly the purpose of this compilations? No, I'm going to give some points here. Compilation in the sense, two things. One is what the conversion from high level language to What next one can know? Low level language, high level language to low level language conversion. And second thing is what there. Now tell me all of you know who has written that program? Who has written that program? Programmer, developer. Am I right or not? Human being only. Developer in the sense what there? Human being. See, human being may go for some number of mistakes in our program. While writing the program, number of mistakes here we are going to do. Definitely, it's a minimum fundamental right for human being committing the mistakes. Am I right or not? Having mistakes in our program is not a crime. Having mistakes in our program is not a crime, is not a wrong thing. It's a common thing for everybody. But without checking whether our program containing errors or not, without checking whether our program contains errors or not, trying to execute the program is a crime. Are you able to follow or not? Without checking whether our program contains errors or not, you are trying to execute our program is a big crime. So what is the point I'm telling there? Before executing our program, first we have to check whether our program contains any error or not. Before executing our program, first we have to check whether our program is having any error or not. If our program is having error, then we have to correct that program again. If no errors are identified there, then program is going to be executed. So definitely we need to perform some error checking or not. In our program, we have to perform some error checking or not. Exactly. That error checking here we are going to do with what there? That compilation only. Compilation is responsible for what there? Error checking. Compilation is responsible for what there? Error checking. Is it all of you are getting clarity on these points now? Is my point is clear to all of you? Right, sir. Now tell me, two responsibilities are available for compilation. What are the two responsibilities now? Come on, one is what there? Converting program from high level representation to low level representation. Second one is what there? Error checking. Error checking is one responsibility. Converting from high level to low level. This is another responsibility. Yes, all of you are getting clarity why we need to go for compilation. No, no response, guys. Fine. Let's come for the next point now. Observe carefully. The time when we perform compilation, is called as compilation time. The time when we perform compilation is what there? Compilation time. Got it or not? The time when we perform compilation is compilation time. Compilation time is also be called as static time. Compilation time is also be called as what there? Static time. Next one. The time when we perform execution, that is called as execution time. The time when we perform execution is also be called as what there? Execution time. Execution time is also be called as what there? Dynamic time. Dynamic time is also be called as what there? Runtime. They are the names, different names. The time when we perform compilation, static time or compilation time. The time when we execute our program, execution time, dynamic time, and runtime. Sir, all of you getting my point or not? Okay, now observe carefully. One more point I'm telling you. For example, int a is equal to 10. I have written this in a section. Int a is equal to 10. Now tell me, for a variable, this is a variable. For a variable, 2 bytes of memory will be allocated or not? Internally, the 10 is the data. The 10 data has to be stored or not? Where the 10 data has to be stored in internal memory. Am I right or not? So here, what we are able to have there, 10 is the data here now. A value and 10 is the data. The 10 data will be provided within what there? 2 bytes of memory. Am I right or not? That means for every data type, on the base of data type, for integer, 2 bytes of memory will be allocated. So this is a primitive data. For this primitive data, memory must be allocated or not? For the primitive data, memory must be allocated or not? Please recognize my point, what I'm telling here. Definitely, memory will be allocated for the primitive data. Clear or not? Okay, now listen carefully. I'm giving conclusion, try to understand it now. If any programming language allows memory allocation for the primitive data at a compilation time, not at runtime, at a compilation time. If any programming language provides memory allocation for the primitive data at a compilation time, not at runtime. That programming language is called as static programming language. That programming language is what there? Static programming language. All of you are getting clarity what I'm telling there? If any programming language allows memory allocation for the primitive data at a compilation time, not at runtime, then that programming language is called as what there? Static programming language. Similarly, if any programming language allows memory allocation for the primitive data at a runtime, not at compilation time. At what time there no runtime, then that programming language is called as dynamic programming language. The programming language is what there? Dynamic programming language. Is that clear or not? Right. So now observe carefully. Of course, I want to give even this diagram also for you. In the document, I will include even this diagram also. Now observe carefully. What is the definition here given there? What is the first difference between Java and others? Now tell me. What is the very first difference here? C and C++ are static programming languages, but Java is what there? A dynamic programming language. Tell me, what is the point I have given there? Yesterday, I think in the last class I given the point here. What was the point I have given there? If any programming language allows memory allocation for the primitive data at a compilation time, then that programming language is called static programming language. Examples for static programming language is what there? C and C++. Observe carefully. Next one is, what is this? How this is a static programming language now? In C and C++ applications, memory will be provided to the data at a compilation time only, not at a runtime. So C and C++ are what their static programming languages. Next one, if any programming language allows memory allocation for the primitive data at a runtime, if any programming language allows memory allocation for the primitive data at a runtime, then that programming language is called as what there? Dynamic programming language. Examples are what there? Java, Python. In Java applications, memory will be allocated for the data at what time here? At a runtime. In Java applications, memory will be allocated for the data at what time here? No? At a runtime. Yes, sir. All of you are getting it or not? What I am telling you now. That's okay now. This is the first difference here, what we identified clearly. Okay, that's okay, fine. Now this is completed. Then what next one here? After completion of this, second difference here we are going to understand. All of you observe carefully the second difference now. Everybody understand it now? Preprocessor is required in C and C++, but a preprocessor is not required in Java. Sir, all of you are getting clarity on this? Preprocessor is required in C and C++, but the preprocessor is not required in Java. Clear? Right. All of you observe carefully. Before going to understand preprocessor is required or not required in C, C++ and in Java, before understanding this preprocessor required or not required in C, C++ and Java, first of all we have to understand what is preprocessor, what is the role of the preprocessor in a programming, where this preprocessor is existed, what it is able to perform, what it is able to do in our programming languages. That all the points here we have to understand. After that we will decide whether preprocessor is required or not required in C, C++ and Java. Yes, sir. All of you are getting it or not? What I am telling you. Right, sir. Now let us understand the content here. What I am telling to you. Observe carefully. I want to give one diagram here. For example, I'm going to write a program. Now this we can understand a C program. Dot C. This is what there? A C program dot C. Observe carefully. Next one is we need to perform compilation. Here we have to perform what there? Compilation. When we perform compilation, now tell me guys, after compilation of our C program, what files here we are able to get? What file here we are able to get? Already we have seen in the previous diagram there. Of course, different files here we are able to get .obj, .ai. Finally here what we are able to get? No, .exe file. That's what we require. After that, whenever we are getting this .exe file, there we can execute our program. So now here we have to perform like what there execution process. Execution process here we have to perform. Whenever we are executing this program now, here directly we are able to get some output. Here we are able to get like what there some output. Right. Now this is the overall scenario here we can understand. All right. Now if we observe this compilation, in compilation is not like only one mission work. Compilation is like 4 missions work. Compilation is not like single mission work. Compilation is nothing but 4 missions work. What are these 4 missions here we are able to provide? First one is like what there preprocessor. First one is what there preprocessor. Okay. Next one after that compiler. After that assembler. Then after that loader link editor. That's it. Observe carefully. First one is like what there preprocessor, compiler. Next one is assembler. Next one is like what there loader link editor. This is overall. Right, sir. Understand it clearly. Now inside this, again now I'm telling there, here the requirement of the preprocessor, location of the preprocessor we understood there. This is sufficient. But I want to elaborate even compiler also. Internally, compiler is also existed. What is available there inside this compiler? Compiler, if you observe this, lexical analysis phase. After this lexical analysis phase, next one is what there syntax analysis phase. After this syntax analysis phase, next one is semantic analysis phase. Next one is intermediate code generation. After this intermediate code generation, code optimization. Then after this, another one is what there code generation. Right. These many phases are available inside the compiler. If you open the compiler, these many phases are existed here. Let's see this the phases what we are having there. Now first one is like what the lexical analysis phase. Next one is the syntax analysis phase, semantic analysis phase, intermediate code generation, code optimization. The next one is like what the code generation. Of course, along with these 2 more tables are available. The 2 more tables are not required here, like symbol table, error handler table. So different things are available here. It's not required for us now. But majorly, this is the total architecture what we are having. Right, of course, I don't require all these concepts immediately. I don't not required to understand each and every point immediately. So from this diagram, what I require the information, what exactly the point here I'm trying to say. From this diagram, we can understand the location of the preprocessor. From this diagram, what we have to remember, the location of the preprocessor. Where is preprocessor? At which location that preprocessor is existed? That point here I require now. Tell me at which location that preprocessor is available? Inside the compilation. Inside the compilation, the very first phase is a pre-processing phase or not? Inside the compilation, the very first phase is what there? Pre-processing phase. Sir, all of you are getting it or not? Only this point. For the sake of this point only, I given this entire diagram here. Okay. Right. Let me provide this point here. Try to observe this clearly. Here the diagram here I'm going to provide. Now tell me what is the location of the preprocessor? Preprocessor is the first phase. Preprocessor is the first phase in compilation. Preprocessor is the first phase in compilation. That's okay, fine. What this preprocessor will do? What preprocessor is able to do? What is its responsibility in programming languages? Observe carefully now. I'm going to give some clarity. Now try to understand it now. All of you observe carefully. In a C and C++, not only in the C, I'm telling that in a C and C++, observe carefully. Every programming language is having some predefined library or not? Come on, guys, you have to respond for me. Every programming language is having some predefined library or not? So in C and C++, the complete predefined library was provided in the form of header files. Am I right or not? If you're having awareness on C and C++, we have to answer for it. The complete predefined library is available in the form of what their header files. Can you tell me examples for these header files? No? stdio.h. Am I right or not? stdio.h. Come on. Next one is like what there? After this stdio.h, math.h. After this math.h. Next one is what there? conio.h and so on. So many things are existed here now. What are the various things now? stdio.h, math.h, conio.h and so on. Just examples I'm telling them. Okay, good. Listen carefully. Okay, predefined library is available in the form of header files. But how I'm going to use them in my C program? The predefined library is available in the form of header files. But how I'm going to access that header files data in my C program then? In C and C++ applications, if you want to use predefined library which are provided in header files, if you want to use predefined library which are provided in header files, then we have to include header files in the C and C++ programs. Am I right or not? We have to include header files into the C and C++ programs. Good. Further purpose, what syntaxes, what we have to use there? Examples I'm telling there. Hash include stdio.h. Am I right or not? Or statement here we have to use there. Hash include stdio.h. Next one is a hash include conio.h. Next one is a hash include math.h. Hash include like what there? Math.h. In this way here we are able to provide this. Am I right or not? Next point is very, very important. Try to observe carefully. For example, I have a program. Inside my program, I have written all the hash include statements. I have written all the hash include statements like this inside my program. Observe carefully. If we compile a C program, C and C++ program, C and C++ programs, then preprocessor will perform the following actions. All of you observe carefully what actions it able to perform there. If we compile C and C++ programs, then preprocessor will perform the following actions. Point number one. Listen, all of you listen carefully. Preprocessor will recognize hash include statements. Hash include statements. Am I right? Observe carefully. Preprocessor will recognize hash include statements. Preprocessor will take all the specified header files names from hash include statements. Am I right? Preprocessor will recognize all the hash include statements. Preprocessor will take all the header files names. What are the header files names I specified here? stdio.h, conio.h, math.h, it able to take all the header files names. Clear or not? Next one, after that, observe carefully. Preprocessor, understand it clearly what I'm telling there. Preprocessor will will check, preprocessor will check whether the specified header files are available in C and C++ softwares. What preprocessor will do, no, whatever the header files name here we specify, no, preprocessor will check whether the specified header files are existed or not existed in the C and C++ softwares. Say for example, if you want to compile my C program, first of all, C software must be installed in my computer or not. In that installed C software, preprocessor will check whether these header files are existed or not existed. Okay, observe carefully. Point number 3. In the case, if the specified header files are not existed, if the specified header files does not exist or existed, the specified header files are not existed in the C library, C predefined library or inside the C software, then preprocessor will raise an error. If they're not available, then preprocessor will raise what there? An error. Got it or not? In the case, for example, right sir, in the case, observe carefully, if the specified header files, if the specified header files are existed in the C predefined library, then preprocessor, observe carefully, preprocessor will load all the header files to the memory as part of compilation. Sir, all of you are getting it or not? All of you are following this point or not? First of all, preprocessor will recognize all the hash include statements. Preprocessor will take all the header files names what we provided. Preprocessor will check them whether they are available or not in the C predefined library. If they are not available, error will be raised. If they are available, then preprocessor will load all the header files content to the memory, part of the compilation. Now I'm giving one point here. Now try to observe carefully. This type of loading predefined library, is called static loading. At compilation time, we are loading that library or not? This type of loading is called as what there? Static loading. Is that all of you get my point or not? Then the preprocessor will load all the header files content to the memory as part of compilation. This type of loading predefined library is called as what there? Static loading. Now response guys, all of you are getting it or not? What exactly the point I'm telling there? Now tell me here, what is the conclusion here I'm telling there? Conclusion, not the point, no, conclusion now. Tell me, by seeing all these points, no, what is the job of the preprocessor in C and C++ applications, no? What is the job of the preprocessor in C and C++ applications, no? The job of the preprocessor in C and C++ applications is to recognize hash include statements in order to load header files content to the memory. To recognize all hash include statements in order to load all header files content to the memory. Because of this particular reason only, here we have used what there? Preprocessor. No response guys, what I'm telling you now. Is it clear or not? Alright, so now. The main purpose of preprocessor in C and C++ applications is to recognize all hash include statements in order to load header files content to the memory. That's it. Now this is, just give a minute of time. Right, sir. So the main purpose of the preprocessor in a C and C++ applications is to recognize all hash include statements in order to load header files content to the memory. Right, so this is what exactly the purpose of like what the preprocessor in C and C++. And the corresponding diagram also here we provided here at which location it is available clearly. But here my question is preprocessor is not required in Java. Preprocessor is not existed in Java. Why it is not existed in Java? Why it is not required in Java? That point here we want to understand. That's our required point here. Why it is not required in the case of Java? Okay, now observe carefully. After this, here I want to provide the point here. Now try to understand it now. In Java, first of all, tell me in C and C++, the complete predefined library is existed in the form of header files or not? Come on, in the form of header files or not? But in Java, the complete predefined library is existed in the form of classes and interfaces in packages. This example is what their packages. Example I'm telling to you, now observe carefully. Example I'm telling to you, now observe carefully. Java.io package, Java.util package, Java.sql package. All these are what their packages. Inside the packages, no classes and interfaces are existed. This is the structure of the Java predefined library. In Java, the complete predefined library is available in the form of what their packages. Java.io, Java.util, Java.sql. Understand it clearly now? Okay, good. Next one is in Java applications. See, in the case of C and C++, if you want to use predefined library, in the case of C and C++, if you want to use predefined library, there we have to include header files to the C and C++ programs or not. Similarly, in Java applications, if you want to use predefined library, then we have to import the packages. What we have to do there? Import. In the case of Java, importing packages. In the case of C and C++, including header files now. Right. Right, sir. Now observe carefully how we are going to write these import statements now. Just I'm giving that import java.io.star. What is the meaning of this star now? In a java.io package, so many classes and interfaces are available. That all classes and interfaces of the java.io I want to get into my program. That's why here I'm using this one. Next one is what there? Import java.util.star. Similar, in the case of java.util package, so many classes and interfaces are available. I want to get all of them. Next one is what there? Import java.sql.star. So here in java.sql package, so many classes and interfaces are available. I want to use them. That's why here we have used this star. Okay, fine. For example, I prepared a Java program. I prepared what there? Java program. Inside the Java program, I have written all these import statements. In a Java program, I have written what there? All the import statements. Now I want to compile my program. Observe carefully. If I compile a Java program, then compiler will perform the following actions. Of course, we already aware about it. In the case of Java, preprocessor is not available. That's why I'm using what the compiler. Compiler will perform the following actions. What actions the compiler is able to perform there? Observe carefully. Understand it clearly. First of all, compiler will recognize all the import statements. Compiler will recognize all the imports. In the case of C and C++, preprocessor recognized what their hash include statements. Now in Java, compiler will recognize import statements. Next one is number 2. Compiler will read all the packages names which we provided along with the import statements. All of you observe carefully. Compiler will read all the package names which we provided along with the import statements. Then after that, observe carefully. Compiler will check whether the specified packages are existed or not in the Java predefined library. In the case of C and C++ also, preprocessor has checked whether the provided header files are exist or not in C predefined library. Here also the compiler has checked whether the provided provided packages are available in the C Java predefined library or not. Then point number 4, observe carefully. If the provided packages are not existed, if the provided packages are not existed in a Java predefined library, then compiler will raise an error. Compiler will raise an error. Am I right or not? If the specified packages are not available in Java predefined library, the compiler will raise an error. Package XXX does not exist. Package java.util does not exist. Package java.sql does not exist. There we are able to get some compilation error. For example, if the specified packages are available in Java predefined library, if the provided packages are existed in the Java predefined library, if the provided packages are existed in the Java predefined library, then what compiler will do? Then compiler will not raise any error. Please remember this, compiler will not raise any error. In the case of preprocessor case, if the specified header files are available, no error, but header files content is loaded to the memory or not. That is called a static loading or not. Now, what I'm telling there, if the provided packages are existed in the Java predefined library, then compiler will not raise any error, and compiler will not load any package content to the memory. In Java, compiler is not loading any package content to the memory. Just compiler is responsible for checking whether the specified packages are existed or not existed. That's it. Yes, sir. In the case of C and C++, preprocessor responsibility is what there? Loading header files content to the memory, static loading. But in the case of Java, compiler is not responsible for checking whether the compiler is not responsible for loading predefined library to the memory. But compiler is responsible for checking whether the specified packages are available or not available in Java predefined library. Is that all of you are getting my point or not? Whatever the point here I'm telling you. Clear. Now this is exactly the point here. What I'm telling to you, this point here. That's okay, fine. This is like what there? Point number 5. All right, sir. Compiler will not load any package content to the memory. Okay. If compiler is not loading this, but who will load this predefined library to the memory? Who will load that predefined library to the memory? All right. If you observe this, if we execute the Java program, if we execute Java application, comma at a runtime, I'm telling there, not at compilation time, JVM will load the required predefined library to the memory. At runtime, not at compilation time. At runtime, JVM will load the required predefined library to the memory. This type of loading predefined library is called dynamic loading. This type of predefined library loading is called as what there? Dynamic loading. Yes, sir. Are you following or not? What are the points I'm telling there? A clear cut information here I'm telling you. Try to follow these points here. Each and every point I'm providing in the document. This document is for the sake of you only. All of you are seeing the document there. Whatever the content here I'm providing there. Of course, at the end of the class, I'll give that link also to you. Already given that link to you. All right. Now tell me. I'm asking one question there. In which programming language static loading is going on? In which programming language dynamic loading is going on? Now tell me. Static loading is going on in which programming language? C and C++. Dynamic loading is going on in which programming language? Java programming language. So static loading is supported by hash include statements, and dynamic loading is supported by import statements. Are you getting it or not? Now let's come for the conclusion, guys. Now the conclusion is what their preprocessor. Preprocessor is not required in Java. Why it is not required in Java? That's the question. Why preprocessor is not required in Java? That's the question actually. Right, now here we have to understand, no, observe carefully. In Java, preprocessor is not required. Why, sir? What is the reason for it? No, why? Because in Java, preprocessor is not required. Why? Because in Java, hash include statements. In Java, hash include statements and header files are not available. Why preprocessor is not required in the case of Java? Hash include statements and header files are not available in Java. Right or not? Now in Java, packages and import statements are available. In Java, alternatively in Java, packages and import statements are available. So here to recognize packages and import statements, Java is able to use compiler and JVM. So it is not required to use what their preprocessor. Because of this reason only, preprocessor is not at all required in the case of Java. So, if you're getting it or not, whatever the point here I'm telling them. That's okay, fine. All right, sir. Now, whatever the diagram here we prepared now, this diagram I want to be converted to Java. This diagram is purely in C. I want to convert this diagram into what there? Java. Let me check this here. What we are able to convert here. Now here dot C is available here. In place of dot C, here we are able to get what there? Dot Java. Listen carefully. In the case of C, after compilation, we are getting .exe file. But in place of this Java, in the case of Java, in place of .exe, we are able to get what files there? Dot class files. In Java, only two types of files. Before compilation, .java. After compilation, dot class files. Alright, sir. Now here we are able to get it. But in the case of Java, what is not available here? No, preprocessor is not available. Remaining content is very same. In the case of Java, preprocessor is not available, but remaining content is very same. Alright, so now this one also here I want to provide in our content here. Try to recognize this. But I have one important interview question, guys. You have to give answers for it. Are you ready for it? My question is, what are the differences between hash include statements and import statements? What exactly the difference between hash include statement and import statement? This is my question. Okay. Can you give answers here? No? Tell me the very first answer here. First of all, where they are available, where these two things are available here. No? First of all, tell me hash include statements are available in C and C++. Similarly, import statements are available in Java. Import statements are available in where there? Java. That's okay, fine. Next one is their functionalities, what they are able to include. Now tell me, all of you now tell me, hash include statements are able to include predefined library Hash include statements are able to include predefined library which are available in the form of header files. Am I right or not? Now tell me. Similarly, here what we are able to provide there, import statements are able to include the predefined libraries, which are available in the form of classes and interfaces in packages. Okay. Next one, loading. Which type of load are which are recognized by preprocessor, which is recognized by compile and JVM. If you observe this, hash include statements are evaluated by or maybe recognized by. Hash include statement recognized by whom? Come on, hash include statements are recognized by whom? Preprocessor, right? Similarly, now tell me, recognized by the preprocessor. But import statements are recognized by the compiler and JVM. Both can recognize. Both has to use these import statements. At compilation time, checking packages, but at runtime, then loading the content point of both has to be recognized. Fourth one, now tell me, all of static loading and dynamic loading. Hash include statement is supporting. Hash include statement is supporting what loading there? Is supporting static loading. Hash include statement is supporting what loading there? Static loading. But import statement is loading. Import statement is supporting what loading here? Now tell me, dynamic loading. Import statement is supporting what loading there? Dynamic loading. Okay, right, sir. Next one is fifth point. Observe carefully. Now tell me, by using a single hash include statement, how many header files we are able to include? Only one header file or more than one header file? Only one header file only. By using single hash include statement, we are able to include only one header file. We are able to include only one header file. Example here I'm telling to you, observe carefully. Hash include yesterday.h. Next one is hash include conio.h. That means if you want to include more than one header file, we have to use more than one hash include statement. That's the point here I'm telling to you. Hash include math.h, like this here we are able to provide. But in the case of Java, what is going on here now? By using single import statement, we are able to include more than one class or more than one interface of the same package. More than one class or more than one interface of the same package by using star notation. We know already. Import java.io.star. Star is representing what there? All, more than one class or more than one interface from the specified package, java.io package. We can understand it clearly now. Got it or not? So this is overall information here. We can understand clearly now. Right, sir. This is the total awareness on. Like preprocessor and its existency in C, C++ and Java. It is required in C, C++, but it is not required in Java. What is predefined library, sir? There is a question now. What is a predefined library? For every programming language, some libraries must be provided by the languages, not by the developers. Some libraries only developers can define, but majority of the libraries must be provided by the programming languages only. That programming languages defined libraries what there predefined library. Understand it? What I am telling you. Okay. All right, sir. Now, all right, sir. That's okay. Fine. Does JDK also include JVM? So this JDK, JVM, JRE, the topics I'll discuss with you later. Don't think much about it now. But at present, we are at very startup mode. Just gradually, slowly, I'm going to increase the content here. So we are able to understand it now. At very starting, in the differences between Java and others, slowly we are going to understand each and every point here now. Right. So then tomorrow, I'm going to discuss one important topic here. Very important here. I think the third difference here. What I'm going to discuss there. C and C++ are platform dependent programming languages, but Java is platform independent programming language. This difference here we are going to understand. Very important difference. Directly interviewers are asking this question there, this difference now. So without failure, try to understand this particular point. So this topic, this point, I'm going to discuss on tomorrow. Tomorrow we are going to see this content, guys. Okay. That's all, guys. That's all for today. Then tomorrow we'll meet. Tomorrow we'll see the remaining content, right? Once again, I'm telling there, few days of time only. Then 5:30 to like 6:30, I'm going to take no. Afterwards, 4:30 to 6, 1.5 hour class we are going to be take no. But in the startup mode, few days of time because of some busy schedule. Few days of time, only 1 hour class I'm planning that. Next onwards, 1.5 hour class we are able to plan that. But I will give schedule to you when onwards. From which date onwards we are going to plan for 1.5 hour class now, right? Thank you. Thanks a lot. Please confirm to me. All of you get my voice on screen. Those who are attending in online. Guys, please confirm to me. All of you get my voice on screen. Those who are attending in online. Hmm? Yeah. Okay. There is. Guys, please confirm to me. All of you get my voice on screen. Those who are attending in online. Yeah, thank you. Right. Good evening, guys. And check it what we completed in the last session. Think so. We are discussing about the differences between Java and others. In the differences between Java and others, what topic here we understand there? C and C++ are static programming languages, but Java is what there? A dynamic programming language. Okay. Then we are given some points here. If any programming language allows memory allocation at a compilation time, then that programming language is a static programming language. If any programming language allows memory allocation for the data at runtime, then that programming language is what their dynamic programming language. Examples for static programming languages are C and C++. Example for dynamic programming language is what their Java and others. Next one is preprocessor is required in a C and C++, but it is not required in the case of Java. All right, what is the purpose of this preprocessor in a C and C++ and why it is not required in the case of Java? If you have to this, preprocessor is required in C and C++ to recognize hash include statements and to load the provided header files content to the memory. But in the case of Java, preprocessor is not required. Why it is not required in the case of Java there? In the case of Java, hash include statements are not available and header files are not available. In place of that, classes and interfaces and import statements are available in the case of Java. This is what exactly the content here we understood there, and some diagrammatic representation, somewhat extra content here are given Now try to recognize the content here now. All right, sir. Diagram also I have given there. The total process I have given, somewhat total content given. Then at the end I have given one important interview question in the last class. What was that question here I have given there? What are the differences between hash include statement and import statement? If you observe this, hash include statements are available in C and C++. Import statements are available in Java. Next one is what there. Hash include statements are able to include predefined library which are available in the form of header files. Import statements are able to include the predefined libraries which are available in the form of classes and interfaces in packages. Hash include statements are recognized by the preprocessor, but import statements are recognized by the compiler and JVM. Hash include statement is supporting static loading, whereas import statements are supporting dynamic loading. By using single hash include statement, we are able to include only one header file. That's like what there. Hash include stdio.h, hash include conio.h, hash include math.h, like this. By using single import statements, we are able to include more than one class or more than one interface of the same package. Import java.ivo.star. Example I given, star is a representation here. The star is representing what there, including all content here now. Then after that, we need to start today the third difference here. What is the third difference here now? C and C++ are platform dependent programming languages, but Java is what their platform independent programming language. Clear? All of you understand it? Put focus on this point here. Before going to understand whether C, C++ and Java are platform dependent or platform independent, before that, first of all, tell me when a programming language is platform dependent and when a programming language is platform independent. That we have to understand first. After that, we are going to think whether C, C++ are platform dependent or not, whether Java is a platform independent or not. Later on, we are going to discuss about it. Right, so now let's understand the point here. Observe carefully. C and C++ are platform dependent programming language. That's okay. Before that, now observe carefully. Listen carefully. If any programming language, yes, if any programming language allows its applications to perform, understand it clearly. If any programming language allows its applications to perform, compilation is on compilation and execution on the same operating system. If any programming language allows its applications to perform compilation and execution, both must be on the same operating system, then that programming language is called platform dependent programming language. This is what the platform dependent programming language. Is it? All of you are getting clarity in this now? If any programming language allows its applications to perform compilation and execution on the same operating system, then that programming language is called platform dependent programming language. Observe carefully. Example is what there, C and C++. An example for this is what there, C and C++. Okay, definition is okay. Example is what there, C and C++ programming languages. Up to this one is also be okay. But how can you say C is a platform dependent programming language? Any proper reason for it? How it is possible to say C is a platform dependent programming language? Any reason for it? Yes, I'll give some reason here. Now try to understand the point here. All of you observe carefully. What exactly the point here I'm telling to you? All of you observe carefully. Right, now see this. For example, I want to take a C program here. This is my C program. C program in the sense what we are able to get here, dot C as an extension here we are able to provide. Okay, dot C. Now inside this C program, we have to write some mini sections. I have written some code. Observe carefully. Whenever we have written this C program, we have to compile this program or not? We need to compile this program. So compilation here I'm going to take. Observe carefully. This is like what their compilation. Now tell me, all of you now tell me, after compilation of our C program, what files here we are able to get now? What exactly the file here we are able to get now? Dot exe file here we are able to get. What file here we are getting there? Dot exe file. Inside the dot exe file, so now here we are able to have like what there some content here. What is this content? I will discuss with you later on, but understand this clearly. .exe file here we are getting. Clear? Whenever we are getting this .exe file, I need to execute this program. Execution here we have to perform. Who will execute our C programs now? Already given that point. Who will execute C programs now? C engine. C engine will execute our C programs. Whenever we execute our C program, there we are able to get some output. After execution of our program, there we are able to get what there some output. This is overall process what we are having. Clear? All of you are getting it clearly? Outputs here we are getting there. Okay, fine. Right. Listen carefully. All of you know. I have taken C program that we compiled. We are getting some .exe file. The .exe file we executed by using C engine. Then we are getting some output. Clear? Up to now. Further definition. Platform dependent programming language definition. Point of view. What I am telling there. For compilation, I need to take operating system. For execution also we require what their operating system. Here, what is the definition of the platform dependent programming language? The definition of the platform dependent programming language is what they, if any programming language allows its applications to perform compilation and execution on the same operating system. That means for compilation and execution, we have to provide what the same operating system. For compilation and execution here, we have to provide what the same operating system. Then that programming language is what their platform dependent programming language. All right, sir. Now here, as per the definition, for compilation, I'm using like what their Windows. For execution, I have to use what there as per the definition Windows only. If we use Windows operating system for compilation, for execution also we have to use what their same Windows operating system. Then only the programming language is what their platform dependent programming language. Get my point or not? For the sake of the discussion, for the sake of our clarity purpose, for execution purpose, I want to use different operating system. And for compilation, I want to use what their Windows operating system. Compilation is on Windows operating system. Execution is on what their Linux operating system that I have used there. For example, for a discussion point of view, for the sake of understanding point of view, I have used this Linux operating system. Good. Observe carefully. C engine is available on which operating system? No? Come on, guys. C engine is available on which operating system? Linux operating system. If the C engine is available on Linux operating system, then what code it able to understand, it able to execute? No. Observe carefully. It is able to execute. It is able to execute only Linux representations. Linux represented code from operating system to operating system. Internal data representation is different. Don't think about it. Same data representation is available in both the operating systems. From one operating system to another operating system, internal data representation is what they're different. Are you getting it or not? Okay, fine. So the C engine is available on Linux operating system. It is able to execute only Linux represented code. Okay, fine. For example, observe carefully. C program I have written. I'm compiling the C program on which operating system? Windows operating system. I'm compiling the C program on which operating system? No, Windows operating system. Getting my point or not? When we compile the C program and Windows operating system, automatically .exe file is created or not? Now, what is the story about this .exe file? What it is available here inside this .exe file? If we have to this, understand the point here. .exe file, .exe file contains directly executable code. .exe file contains directly executable code. And listen carefully. This point is important. And it is having the local operating system representations. That is what they now here what we provided. Windows operating system representations here we provided. Is it? All of you understand this point here? What is this .exe file nature? No, .exe file contains directly executable code, and it is having the local operating system representations, that is Windows representations. Now this .exe file is having which representations? No, Windows representations. Got it or not? But observe carefully. C engine is available on which operating system? Linux. It is able to understand only what representations? No, Linux represented code. Fine. For example, I got this .exe file which has Windows operating system representations. If I give this .exe file to the C engine, is it possible for C engine to execute this Windows represented .exe file? Come on guys, answer for my question now. If I give this Windows represented .exe file to the C engine, is it possible for C engine to execute Windows represented .exe file? Possible or not possible? Not possible here. It is not possible here. Understand my point clearly. It is not possible to execute. It is not possible to execute. It is not possible to execute Windows represented executable code on Linux operating system. Why? Because C engine is able to understand only Linux representations. So some mismatch is available or not? We are providing Windows representations, but C engine is required what their Linux representations. So some mismatch is available or not? So because of this mismatch, because of this particular reason, we are unable to execute our program. Okay, but if you want to execute this program, then what we have to do? No, only one solution. What is that solution? No, at runtime we have to change your operating system. At runtime, what operating system here we have to provide? The same Windows operating system here we have to provide. On this Windows operating system, if you provide Windows operating system, C engine is able to execute only. Now at present, now we have to remove that Linux. There we have to provide what there? Windows representations. Now observe carefully. C program we compiled on Windows operating system. We are getting .exe file. This .exe file contains what there? Windows representations only. That Windows represented .exe file, if we provide to the C engine, which is on Windows operating system, there we are able to, that C engine is able to execute that Windows represented .exe file or not? Why? Because now C engine is available on what there? Windows operating system. It is able to understand only what there? Windows representations. Now we are providing Windows represented .exe file or not? You are providing what there? Windows represented .exe file. So C engine is also expecting the same Windows operating system representations. So finally, the C engine is able to execute this .exe file or not? Then we are able to get output or not? No response, guys. Right, sir. Because of this reason, C and C++ are what their platform dependent programming languages. That execution is totally depending on the operating system which we have used for compilation. Right, execution of the C program is depending on the operating system which we have used for what their compilation. This is what exactly the meaning of like what their like platform dependent programming language. Clear? All of you are getting clarity on this now? Right, so now let me take this diagram here. I want to keep this one. All right, so let me have one line data. I want to provide some data here. Now try to understand the same point here. I want to say no. If we compile C program on Windows operating system, if we compile C program on Windows operating system, then the compiler will generate .exe file contains directly executable code, and it is having the local operating system representations, that is Windows representations. In this context, to execute Windows represented .exe file, that is to execute Windows represented.exe file. Observe carefully. In this context, to execute Windows represented.exe file, Windows represented.exe file, then what we have to do there? We have to provide, we have to use the same Windows operating system, at a runtime. Right, sir. Due to this dependency, on the operating system, C and C++ are platform dependent programming languages. Yes, sir. All of you are getting my point or not? Clearly, no. That's it, guys. Then how C and C++ are platform dependent, that we understood clearly. Okay, that's okay, fine. The content also here we provided. That's okay. But what is platform independent programming language? Before that, have you understood that the platform dependent programming language content? Can I go for platform independent now? All right, observe carefully. What you are able to understand about this platform independent programming language, what we are understanding there? All right, what is the definition for it? Observe carefully. If any programming language, observe carefully, if any programming language allows its applications to perform compilation is on one operating system, and execution is on another operating system. Compilation is on one operating system and execution is on what there? Another operating system. Then that programming language is called, as what there? Platform independent programming language. That programming language is what there? Platform independent programming language. Clear? All of you are getting clarity on this now? If any programming language allows its applications to perform compilation on one operating system and execution is on another operating system, then that programming language is called platform independent programming language. Right, sir. Example is what there? Java. Of course, Python is also be platform independent programming language. But anyway, Python is not in our context here. First, we have to understand what there? Java. Java is in our context clearly. Getting it or not? Fine, sir. Observe carefully after this. What next point here? I'm telling to you how Java is a platform independent programming language. How Java is a platform independent programming language. We have to understand this point clearly. Understand it now? I'll take another diagram. Observe carefully. For example, first of all, I want to provide the diagram as per the definition. As per the definition, I want to provide this diagram. All right, so now here we can understand .java. Lines of code here we have written .java. Okay. Next one is what? After this, we have to perform compilation. We have to perform like what there? Compilation. Okay. When we perform compilation, in the case of Java, what files here we are able to get? Yesterday already we understood. In the case of C, C++, after compilation, we got what there? .exe file. But in the case of Java, after compilation, what files here we are able to get there? There we are able to get, what files here we are able to get there? No, class files here we are able to get. Right, now we can understand clearly. There we are getting some class file. dot class file. Okay. Whenever we are getting this dot class file, then what next one here we have to do then? Dot class file. Now, I want to go for multiple executions. No, inside the dot class file, some code is available. I will discuss about it. What exactly the code is existed here. Now understand it. No. First of all, I want to execute this program. This is execution. Here we are able to have some output. Execution, and this is like what their output. Understand this? No. Here we are able to provide observe carefully. Execution here we provided here. Now, for compilation, we require one operating system. For execution also here we require an operating system. What operating systems I want to use, I'll discuss with you later on. This is one-time execution. Here I have to provide like what there. Another time execution. And another one. Another time execution here we are providing. Right, observe carefully. After this, after completion of all the content here, then what we have to do? Now I want to confirm the operating systems. Can you tell me what is the definition of the platform independent programming language? Come on, what is the definition of the platform independent programming language? If any programming language allows its applications to perform, compilation is on one operating system and execution is on another operating system, then it is what their platform independent. Please remember that what I'm telling is central point. Platform dependent, compilation and execution must be on the same operating system. Platform independent, compilation is on one operating system, execution is on another operating system. That's it. The central point we have to remember now. Okay, right, son. For compilation, I want to use, for example, Windows operating system I want to use. Now here, how many times we want to execute our program? 4 times we want to execute our program. Am I right or not? All right, sir. In 4 times, then one time here we want to use what their Linux operating system. In another time, I want to use like what they say, for example, Mac, right? Mac operating system, MacBook. In another time here, I want to provide like what they say, for example, Unix, I want to use there, or maybe Solaris, I want to use there. Solaris operating system. Maybe another time here I want to use the same Windows operating system, of course. For compilation Windows and for execution also, I can use that Windows kernel. Understand my point? These many operating systems here we want to use there. Good. Observe carefully now. I'm going to give that exact points here. Now try to understand it now. When we compile Java program on Windows operating system, here what file here we are getting now? What file here we are getting now? Dot class file here we are getting. Then what is the nature of the dot class file? Before going to understand dot class file, what is the nature of the .exe file? Now tell me, what is the nature of the .exe file? .exe file contains directly executable code, right? So .exe file contains directly executable code, and it is having the local operating system representations. That is what their Windows representations. Clear or not? But now come for this dot class file now. What exactly the nature of the dot class file? Observe carefully. Dot class file contains bytecode. Tell me, dot class file contains what code here? Bytecode. What is this bytecode actually? It is not directly executable code. No, it is not directly executable code. .exe file contains executable code directly, but it is not having directly executable code. Answer my point here. Okay, then which code it is available here? No, it is an intermediate code. It is what there? An intermediate code, not a source code, not directly executable code. In the middle one, it is an intermediate code, and it doesn't have or doesn't follow any operating system representations. It doesn't have any operating system representations, including Windows operating system, including Windows representations. Even though we compiled our Java program on Windows operating system, the generated class file doesn't include Windows representations even. All of you are following this point now? Identify the difference between .exe file and .class file. .exe file contains directly executable code, but .class file doesn't have directly executable code. Even it is not representing any operating system representation. It is a neutral bytecode. It is an intermediate code. It is an intermediate code. Okay, please remember this point. This is .class file representation now. But there is a point here. What's the point now? If you want to execute any bytecode on Linux operating system, that bytecode must have Linux representations. If you want to execute any code on Mac operating system, that code must have Mac representations. If you want to execute any code on Solaris operating system, that bytecode must have Solaris representations. If you want to execute anything on Windows operating system, that bytecode must have Windows representations. Clear? All of you are getting clarity on these points now? If you want to execute any bytecode on any of the operating system, that bytecode must have the respective operating system representations. Then only that code will be executed. Follow or not? My point, what I'm telling to you now. Okay, right. Observe carefully. Now, here .class file is generated. Is this .class file is having any representations? Any operating system representations are available with this .class file? No. But I want to execute this on Linux. I want to execute the same thing on Mac. I want to execute the same thing on Solaris. I want to execute the same thing on Windows. That is my requirement. Why? Because now we have taken Java as a platform independent programming language. When Java is a platform independent programming language, one time if we compile the program on Windows, the same thing we can execute on any of the operating system. That's a capability. But how it is possible in the case of Java? That point here we are understanding now. All right, now understand clearly. If you want to execute this bytecode on Linux now, this bytecode must have Linux representations. If you want to execute this bytecode on Mac now, this bytecode must require Mac representations. If you want to execute this bytecode on Solaris now, that bytecode must have Solaris representations. If you want to execute this bytecode on Windows now, that bytecode must have Windows representations. Sir, all of you are getting it or not? All right, now observe carefully. But directly this bytecode doesn't have Linux or Mac or Solaris or Windows representations. It doesn't have any of these representations. But still, how we are going to represent this? How we are going to execute this program? Right, exactly. In this particular situation, so problem is coming or not? Here, this is having neutral bytecode, but here we require local operating system represented bytecode. So here some mismatch is coming or not? Exactly. In this particular situation, to make Java as a platform independent programming language and to run Java applications on multiple operating systems, Sun Microsystems has provided a set of converters, a set of translators to convert our bytecode from neutral nature to the local operating system representations. Sun Microsystems has provided what there? Some converters now. What converters are provided by Sun Microsystems? Care. Observe carefully. Here, Sun Microsystems has provided some converters. Observe carefully. Here, Sun Microsystems has provided one converter, and here another converter. Here another converter, and here another converter. Multiple converters are provided by Sun Microsystems. We can understand clearly. Converter. Now here we can understand like what there converter. Here this is like what I am telling there. Converter. And here we have to provide like what there another converter. Like multiple converters are provided here. What is the job of this converter now? Tell me. The job of this converter is if we provide this neutral bytecode to the converter, converter will convert this neutral bytecode into Linux representations. that Linux represented bytecode will be given to this execution. Execution will be performed on the Linux bytecode and it will provide some output. Again, if we give this neutral bytecode to this converter is able to convert that neutral bytecode into MAC representations, and that MAC represented bytecode will be given to the execution. Execution will be performed on the MAC represented bytecode and providing some output. Right, next one. If we give this neutral bytecode to this third converter, it is converting that neutral bytecode into Solaris representations, and the Solaris represented bytecode will be provided to the execution. That execution is going to be performed on the Solaris represented bytecode, and some outputs here we are able to get. Finally, if you provide this bytecode to the Windows, that means converter, this converter, 1 minute wait, this converter will convert that neutral bytecode into that Windows representations. Windows represented bytecode will be provided to the execution. That execution is going to be performed on the Windows represented code. There we are able to get some output clearly. Is it? Are you getting my point or not? Okay. Now, so here we are getting the Sun Microsystems has given what their converters to make Java as a platform independent programming language and to execute our Java program in multiple operating systems. But here the question is, how Sun Microsystems has provided these translators? How Sun Microsystems has provided these converters actually? How Sun Microsystems has provided these converters actually? If you come for this point here, answer is very clear. Sun Microsystems has provided these converters and execution, this conversion and execution both in a single mission. Sun Microsystems has provided this conversion mechanism along with execution in a single mission. This is a single mission. Here also be conversion and execution both are provided in a single mission. Right, sir? In all the cases, conversion and execution both are provided in a single mission. Here, the name of this single mission, which has conversion and execution process, the name of that single mission is what there? JVM. The name of that single mission is what there? JVM. Here we require one JVM, here we require another JVM, and here we require what there? JVM, another JVM. Guys, observe carefully. Then what is this JVM actually? Java Virtual Machine. What is the job of the Java Virtual Machine here? Two responsibilities are available. What are the two responsibilities? No, converting bytecode into the local representations and executing that local bytecode. The local represented bytecode is called as a native code. Local represented bytecode is what their native code. See, after converting this bytecode into Linux, no, Linux represented bytecode is available. That is called as native code. After converting into MAC representations, MAC represented bytecode is available now. That is what their native code. So JVM is converting bytecode to native code and executing that native code. So anyway, JVM responsibilities are two. What are the two responsibilities? No, one is a conversion. Second one is what their execution. Conversion is from what to what? Converting from neutral bytecode to local operating system representation. That is what their native code. Converting from bytecode to native code and executing that native code. These are responsibility of the JVM. All of you are getting clarity or not? Now one straight question I'm asking to all of you, now try to answer for it. How many times we compiled our program here? How many times we compiled our program? Only one time, right? Only one time only we compiled our program. But how many times we executed our program? How many times we have executed our program? 4 times we have executed our program or not? See, observe carefully. 4 times we executed there. One time we compiled our program, but 4 times we execute our program. Now tell me, all 4 times on a different operating system we have executed. We executed our program 4 times in a different operating systems. Am I right or not? Now here my question is, for the 4 times execution of our program, how many JVMs here we have used them? For 4 times execution of our program, how many JVMs here we have used them? Come on guys, now tell me how many JVMs here we have used. Is it single JVM or 4 JVMs? Come on, think and give the answer now. Is it single JVM or 4 JVMs now? Single JVM or 4 JVMs now? Right, answer is what there? 4 JVMs, not single JVM. Not single JVM, 4 JVMs now. How sir? How can you say 4 JVMs can now? Please recognize my statement now. Java is a platform independent programming language because of JVMs only. Java is a platform independent programming language because of what there JVMs only. But JVM is a platform dependent one. JVM is what there platform dependent. Java is a platform independent programming language, but JVM is what there platform dependent. Clear? All of you are getting clarity on this? Java is what their platform independent programming language, but JVM is what their platform dependent. JVM is what their platform dependent. Clear? All of you are getting clarity in this point now? All right, sir. This is a clear-cut information here. We can understand about the JVM and its platform dependence now. Not only JVM, the complete Java software. Java programming language is different. Java software is different. The complete Java software is a platform dependent. The total Java software is what there platform dependent. Inside the Java software only, we are having Java compiler, JVM, Java Docker, and all so many tools are available. All the tools collection is nothing but Java software. All the tools are platform dependent. Java compiler is platform dependent. Java JVM is platform dependent. Java documentator is a platform dependent. Java profiler is a platform dependent. All these are the Java tools. All these Java tools are platform dependent, but Java programming language is what they're platform independent. So all these tools are available inside the Java software. Java software is a collection of these tools only. So Java software is totally what they're platform dependent, but Java programming language is what they're platform independent. Yes, sir. All of you are getting clarity or not? Right. So now let me take this particular diagram here. Now let me go for it. Later on, of course, I'm going to write the content here. Right, sir. Example for this is what there Java. Java is the best example for what there platform independent. But let me give some points here about it now. Right, sir. If we compile Java program on Windows operating system, if we compile Java program on Windows operating system, then the compiler will generate dot class file, right, sir? Then the compiler will generate what there dot class file, right, sir? It contains what code here? Now tell me byte code. What is the nature of the byte code? It is not a directly executable code. It is not a directly executable code. Okay, what is this actually? It is an intermediate code. It is an intermediate code, and it is not having any operating system representations. And it is not having any operating system representations. Okay, fine. This is a punch kernel. But observe carefully. In this context, in this context, if you want to execute, bytecode on any operating system, if you want to execute bytecode on any operating system, then that bytecode must have the local operating system representations. In this context, if you want to execute bytecode on any of the operating system, then the respective bytecode, then that bytecode must have the local operating system representations. Right or not? In this context, to make Java as a platform dependent programming language, Sun Microsystems, to make Java as platform dependent programming language, Sun Microsystems has provided some conversions or some translators, some conversion mechanisms to translate bytecode from neutral nature to, from what nature can know, neutral nature to the local neutral representation to the local representation. Okay, neutral representation, right? This is a punch kernel. But how Sun Microsystems has provided this conversion mechanism can know, observe carefully. Sun Microsystems has provided Sun Microsystems has provided the conversion mechanisms. Sun Microsystems has provided the conversion mechanisms along with the execution in the form of JVM, in the form of what there JVM. What's the meaning of the JVM here? Java Virtual Machine. In the form of JVM only here we are able to get it. Java Virtual Machine. Got it or not? This is a clear cut information here we have to understand. Now here I want to give some conclusions, guys. Now try to understand these conclusions here. What conclusion here I am telling to you? Observe carefully. Java is a platform independent programming language because of JVMs only. Java is a platform independent programming language because of what there? JVMs only. But JVM is a platform dependent tool. But JVM is what there? A platform dependent tool. JVM is what there? A platform dependent tool. Yes, sir, got it or not? So this is what exactly the point here I'm telling to you. Now try to recognize this clearly. Java is a platform independent programming language because of JVMs only, but JVM is a platform dependent tool. One small note here I'm telling there. What is the note now? Right, sir. Java is a platform independent programming language. Java is a platform independent programming language, but Java programming language. Java programming language is a platform independent programming language, but Java software is a platform dependent. Java software is what there? Platform dependent. Right, sir. Observe carefully what I'm telling to you clearly now. Right, sir. Right, sir. Now this is a clear-cut information here we can understand. Java programming language is a platform independent programming language, but Java software is what there? Platform dependent here now. All of you are getting clarity up to know. Now here I have a question, one important interview question here I'm having there. What is that question here we are having there? Observe carefully. My question is, what are the differences between .exe file and a .class file? What are the differences between .exe file and .class file? Now here we have to give answer for this question. What are the differences between .exe file and a .class file? Right, sir. Answer for this clearly. Some answers are available. First of all, in which programming languages these things are existed here, that we have to understand. Now tell me, .exe file is available in C and C++. Next one is what there? .class file is existed in Java. Is existed in what there? Java. Okay, fine. Point number 2. Now observe carefully. What they are containing? .exe file contains directly executable code. Okay, but what about this .class file? .class file contains .class file contains what? .class file contains bytecode. What's the nature of the bytecode? It is not a directly executable code. What is this actually? It is an intermediate code. This is what there? An intermediate code. Right, sir. Point number 3. Which code is dependent on the platform now? .exe file or .class file? Which file is having platform dependent code? .exe file contains what there? Platform dependent code, but .class file doesn't have platform dependent code. It is a neutral bytecode. Answer my point now. So I can say that .exe file is a platform dependent. .exe file is what there? Platform dependent. But whereas .class file is platform independent. .class file is what there? Platform independent. Right. One more point I'm telling there. Observe carefully. .exe file is able to provide lesser security. .exe file is able to provide what there? Lesser security. Dot class file is able to provide more security. Lesser security, and what next one here? More security. Why? Because I can give multiple reasons for this particular security point of view. Point number one, if you compare C and Java, C is a lesser secure programming language when compared with Java. So dot class files, .exe files are having less security when compared with the dot class files. This is one reason. Another reason I'm telling there, in outside also, majority of the viruses related softwares are provided in the form of .exe files, but no virus related software is available in the form of dot class file. Even viruses, if you want to introduce, no, .exe file is a suitable one, but dot class file is not suitable for what there virus related things. No, sir, all of you are getting my point or not? So because of that reason also we can conclude that .exe file is able to provide less security for the data, whereas dot class file is able to provide what there more security for our content. Why? Because .exe file is directly executable code. If I include virus related software, directly it will be executed. But dot class file is not directly executable code. It is an intermediate code. Even if we include virus there, it is not executable directly. Understand my point here? So which one is more secure and which one is less secure one? No. Alright. Dot class file is what there more secure, but .exe file is what there lesser secure one. So in this way we are able to understand the content clearly. Right, sir? So this is overall information about what there platform dependent and platform independent content. Right? Lesson number 3. Here we understood the differences reference between Java and others. If you have to this, that difference, third difference here we understood clearly. Right, sir. All of you are getting clarity? Can I move forward? Can I go for the next one? All right, sir. The next one is like what I'm telling to you. Observe carefully. The fourth one, fourth difference here, what I'm telling there, pointers are existed in C and C++, but pointers are not existed in Java. Pointers are existed in C and C++, but pointers are not existed in Java. That's a point here. Okay. What is the meaning of this pointer? What exactly the meaning of this pointer? Okay. What's the time now? 6:30 almost. Okay. Then tomorrow, no, not on tomorrow, guys. The first weekend, this Saturday and Sunday, I'm not going to take classes for you. Next class will be on what there? Monday. Okay. Monday. What's it? Any occasion on Monday? No, no, no such kind of holidays. Class is there. Max class is there. Don't worry. So this Saturday I'm able to take no, but already I had some commitments there for other batches. No, I have to take somewhat sessions for them. Start tomorrow and day after tomorrow. Don't worry. Then once if I start object orientation on Saturday and Sundays also we are going to have sessions. Yeah, actually the point is what there no holiday scheme actually max. I'm going to follow that, but we are at very startup mode. But we need to set right. We need to be in a right track. Then once if we start it, definitely we are going to have long sessions. On Saturday, once if I start object orientation, Saturday and Sunday minimum 3 to 4 hours of time. I'm going to take for you on weekends. Then don't worry for it. We are able to get more content. But this 1 hour class, the few days of time, max 1 week of time. From this point onwards, 1 week of time. After that, we are going to have 1.5 hour session. On weekends, more sessions we are able to have. No need to worry for it. But content wise, we are completing almost all 1.5 hour equivalent content I'm covering there within 1 hour in our understandable format. So no problem. Actually, this today's topic I used to take up to 1.5 hour of time. But all of you are understanding the point here. But the point is what there, how it is possible. No, less members are available in this class now. That's why I can manage it. If more members are available, automatically it's going to be slow down. Slow down in the sense it may take the same explanation I'm going to provide in general 1.5 hour time, 1 hour 20 minutes I used to take now. But today we understood clearly within 1 hour of time. That's a good thing, good sign now. Okay. Anyway, if you have any doubt for it, just we can watch that video. Document anyway is available. Now try to read the document. Each and every point here we are able to understand clearly. Got it or not? So don't worry. Then Monday I'm going to continue this point here, this particular topic. Thank you. Thanks a lot. We'll see you on Monday. Please confirm to me. All of you are getting my voice on screen. Those who are attending in online, guys, please check it. All of you are getting my voice on screen. Guys, please confirm to me. All of you are getting my voice on screen. Those who are attending in online. Guys, everybody, please respond for me. All of you are getting my voice on screen. Right. Thank you. Thank you. Thank you. Right. Good evening, guys. And just on Friday, I think so. I've taken one demo class. The continuation part here we have to discuss there anyway. So let us check the content what I discussed it there on the Friday class. See this Java is available in how many parts there? Come on. Java is available in how many parts? 3 parts. What are the 3 parts there? J2SE, J2EE and J2ME. J2SE is providing only fundamentals of the Java. By using fundamentals, we are able to prepare standalone applications. Standalone application are like what? Calendar in our computer, calculator in our computer, like this. How many applications are standalone applications there? Only 5% of the applications are what there? Standalone application. What is standalone application? If you have to this, if we prepare and execute any Java application without using client server architecture or without distributing application logic over multiple machines, then that application is what? Standalone application. All right, sir. Its direct utilization is only 5%, but its dependency level is what? There 1000%. To learn J2EE, to work with J2EE applications, to work with the Selenium testing, to work with the Salesforce, and to work with the Hadoop, and so on and so on and so on. 95% of the situations we have to use what there? J2SE. So it's a dependent technology. Okay, clear. After that, next one is like what there? J2EE. Java 2 Enterprise Edition. It will provide server-side programming. It can be used to prepare enterprise applications or distributed applications. If we design and execute any application on the basis of client-server architecture or by distributing application logic over multiple machines, then that application is called as distributed application or enterprise applications. 95% of the applications are what there? Distributed applications only. Examples are given: all banking applications, all insurance applications, all social media applications, all food delivery applications, or healthcare applications, and so on and so on and so on. All these things are like what there? Like enterprise applications only. Last one is what there? J2ME. Java 2 micro edition. It's able to provide what programming here? No, micro programming. By using this micro programming, what type of applications here we are able to prepare there? Mobile based applications. How many applications are mobile based applications nowadays? No, 100% of the applications are what there? Mobile based applications. All right, next point is what we are given there. This is important. Mobile application development has very good demand in outside, but J2ME is not having any demand. It's almost all dead in outside. Okay, right. So these are the things here we have to understand clearly about this J2ME part. Right, out of all these things, J2SE and J2EE are live at present in Java. J2ME is not required. No need to learn J2ME. We can leave this one. Okay, leave this content here. All right, after this, after completion of this particular one, understand the next one again. Today, I think all of you are having syllabus sheets, right? I think all of you are having syllabus, right? Or else, even after completion of the class, you are able to get a WhatsApp message about this syllabus now, content, what I'm going to discuss with you. All right, if you want to observe this, or else maybe just 2 minutes of time, if you want to see the syllabus content here, I can give list of content here now. So many content concepts are available. I'll give that list of content here. Let me give some list now. After that, I'll start our introduction content clearly. Right, sir. First one is like what their introduction, and second one is like what their steps to prepare first Java application. Then after this, steps to prepare first Java application. Third one is what their language fundamentals. After this language fundamentals, object orientation. Oops, this is very very important. This is the heart of the Java, object orientation. Everybody must understand this oops. Without knowing that oops, we are unable to understand anything in Java. Right, next one is after completion of this object orientation, the next topic will be like what there, some wrapper classes, and the next one is like what there, some inner classes. Next, seventh one is like what their packages. After this, eighth one is what their string manipulations, string operations. This is also be important content. String operations. So many times here we are going to use the string operations there in every project. As a common operations we are going to perform. Comparing two names, checking whether the email ID is a proper email ID or not. Anything, all the things here we are going to do. And frequently we are going to use in our applications here now. Next one is like what? Then after this, string manipulations. Next one is we need to go with what their exception handling. This also be another important one. After this exception handling, next one is like what there, multi-threading. Multi-threading is also be another important one. After this multi-threading, next one is what there, IO streams. IO streams is okay, little bit, not completely. Then little bit important one here. Few topics are important. After completion of this IO streams, no, next one is what there, networking, outdated, but still we are going to discuss there as part of our content here. Next one is RMI, remote method invocation. After this RMI, next one is like what there, arrays topic I will discuss here at the 14th topic. 15th one, like what there, collection framework. This is another important. After the object orientation, the second important topic is what there, collection framework. Next one is what there, string manipulations, exception handling, and multi-threading or nominal. After completion of this collection framework, then what next one here we are going to understand there, reflection API. After this, the 17th one was there, annotations. Then after completion of these annotations, the next topic will be like what the GUI part. In a GUI, AWT, and next one is like what their Swing. Even though they are outdated, but little bit awareness I'm able to provide. Why? Because just idea, not utilized in outside. Not just idea I want to provide. Their internal topics are important, but concept-wise it's not required. But their implementations are important. That's why I'm going to discuss about it. After completion of this, next one is like what there, JVM architecture. After this JVM architecture, we are going to understand garbage collector. After this garbage collector, next one is like what are the regular expressions. After this regular expressions, another topic is like what there. Right, sir. Now here, another content here. Introduction, inner class I covered. Okay, fine. JVM architecture, garbage collection, regular expressions, internationalization. Internationalization. Then after completion of this internationalization, all right. Anyway, in the list of topics here I'm giving there, if any topic if I miss no, then non-flow I'm going to be covered here. After completion of this content here, Java 8 version features. Java 8 version features. Right from Java 8. Next one is like what there, Java 9 features, and so on and so on and so on, like this. Maybe almost 35 to 36 now here. At present, I think so. As per your say, Java 20th version, I think so. It's available, right? You said to me, yeah. Java 20th features also. I'm going to prepare. I'm going to explain to you. But as of now, I'm not having awareness on Java 20th. Up to Java 19th, okay. But I can discuss that. But I'll update it. It's a matter of one day. I'll discuss even up to Java 20th version there now. So these are overall the topics here. What we are having there clearly. If any one or two topics might be missing here, but overall content here I'm going to discuss with you. Huge content, heavy content. Why? Because it's a core Java, fundamental. If you know fundamentals, no, then only we are able to understand what their remaining content effectively. Without having these fundamentals, we are unable to understand the Java in the future. That's why I'm going to discuss more and more about this particular content. Got it or not? Just only headlines, only titles I have given. If I take each and every title, where internally more content is going on. So that I have to discuss there clearly. Fine. All right, so after that, after understanding this, now let's come for the introduction part today. Introduction. In introduction, what topics are available? What exactly the content is available in the introduction part here? Observe carefully. What exactly the content is existed here? Observe carefully. Inside the introduction topic. First one is Java history. Why Java is coming into the picture? Who has provided this Java? Huh? What exactly the work that Java people have done to prepare the Java programming language? All these points. The content here we are going to understand Java history. After this, differences between Java and others. Here others in the sense like what there C and C++. Why Java is coming? What differences you identified between Java and other programming languages like C and C++? What differences you identified there? Why Java is the best when compared with the C and the C++? And moreover, some people are having awareness and like what there. To learn Java, first we need to learn C++. To learn